Hello and welcome to the Thursday, December 4th, 2025 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich, recording today from Dallas, Texas. And this episode is brought to you by the SANS.edu Credit Certificate Program in Cloud Security. In Diaries today, I wrote about some observations from our web application honeypots. Lately, we have seen a number of requests that included various headers that looked like these requests went through CDNs like Cloudflare, Fastly, Akamai, and others. This could have a number of different reasons. My first guess is that there's an attempt to bypass CDNs. Many websites are behind CDNs like Cloudflare, Fastly, and rely on them for some basic filtering and also denial of service protection. The problem is that often it's not too terribly difficult to figure out the actual IP address that a website is being hosted on, and then an attacker may connect to the web server directly without going through the CDN. Now, some web applications protect themselves from this bypass by checking if the requests include specific headers that are being added by the CDN. Now, if you're doing this right, there are specific headers that you're supposed to use that contain like random values that an attacker isn't supposed to be able to predict. And that way you can reject some of these bypass requests. But my assumption at this point is that, at least to some extent, well, attackers hope that you're not checking all that carefully. Also, there is a chance that some of these requests actually went through the CDN, and that, for example, some of these headers are implicating that a request went through Cloudflare's warp system, which is kind of like a VPN and could be used by an attacker to actually obfuscate the origin of some of these attacks. And if you are running a website that takes advantage of React, particular React server components, well, I have some bad news for you. There is a critical vulnerability that was patched today that you must patch quickly. This vulnerability was originally discovered last weekend. React was really fast in rolling out a patch for this vulnerability. Even if you don't implement any React server functions, just having React server components installed and enabled will make your application vulnerable. That also then includes various additional frameworks that are enabling React server components for you, like, for example, Next.js. Next.js assigned its own CVE number to this vulnerability, but fundamentally same vulnerability, and it's a basic React vulnerability. So again, patches have been released. I have seen various supposed exploits for this vulnerability being posted. Haven't really been able to verify any of them. Some of them certainly look somewhat fishy. And again, be careful with any sort of high news vulnerability like this. We tend also to have some fake exploits being released that really just exploit whoever is running the particular script. So not sure if we have a working public exploit at this point, but a lot of details have been already discussed about this vulnerability. It's basically a deserialization vulnerability. And based on the patch, there has already been a lot of decent speculation about how to exploit this vulnerability. So likely some of these exploits that I have seen being posted are at least partially working. The security company Wiz has also published a blog post about it and state that they have been able to create a reliable exploit for this vulnerability. So speed really matters in this case. You must have this patched before the weekend, and even that is probably not quite fast enough. Assume compromise at this point for your application, because by the time you're listening to this, well, it's probably already Thursday morning, which means sort of 12 hours later. And at that point, I would expect a working exploit to be publicly available and already being used to scan the internet for any vulnerable systems. And then we have a number of vulnerabilities in a security tool that many users of AI models are relying on to test if the AI models they're using are safe. The problem that this tool, PickleScan, is attempting to address is that when you're downloading a model for use with PyTorch, you're typically downloading a pickle file, which essentially is Python code. And with that, there's always the usual deserialization problem that some of that Python code may actually execute and not just contain data or weights in AI speak. Well, PickleScan itself is a decent tool, well respected. However, it did suffer from a number of basic vulnerabilities. For example, one of the 3 vulnerabilities relates to zip files, where a bad CRC checksum could prevent PickleScan from outright scanning the entire file, and with that, the file would actually still be used and could contain malicious code. There is an update available, so if you're relying on PickleScan to screen your models before you're using them, well, please update, but realize that tools like this in general have various bypass vulnerabilities, so some sound judgment in what models you're using is still appropriate. Well, and that's it for today. So thanks for listening. Thanks for liking. Thanks for subscribing. And as always, special thanks for leaving good comments in your favorite podcast platform. And talk to you again tomorrow. Bye.